Hello, students. Welcome to my YouTube channel, CS Concepts by RVS. We are starting with scheduling algorithms from the subject operating system. There are several scheduling algorithms. In today's session, I'm starting with FCFS scheduling. Fine. Okay. Let's start with the session. What is FCFS scheduling is all about? Right. FCFS, as the name says, it is first come first serve. So it is, what do you mean by this? First come, first serve. That is, the first process that comes into the system, that comes into the ready queue, would be the first process that gets served, right? So among several scheduling algorithms that exist, I can say that FCFS is the simplest CPU scheduling algorithm, right? So here the process will be allotted with the CPU in the order of their arrival, right? So their burst time will not be considered here, whether the burst time is big or small, large or small. So it will not be considered here. Only the arrival time of the process will be taken into consideration, and hence we can also call this as FIFO approach. That is, the first process that enters the ready queue would be the first process that to leave the system as well after getting processed. Right. So let's see some of the characteristics of this FCFS scheduling. First of all, and the important one is it is non-preemptive, which means once a process is allotted with the CPU and the execution of it starts, we will not be able to preempt it even if an higher priority process enters the queue, right? So when it comes to the order of execution, this particular scheduling algorithm provides a fair service, whereas with respect to waiting time, we can't say that this is an optimal scheduling algorithm. And when it comes to the implementation part, I can say that we can make use of queue data structure in order to implement this FCFS scheduling. And as I told earlier, the execution depends on the arrival order and not on the burst time. And so then how this works, how FCFS works, right? So generally what happens when the process enters the ready queue, then it will go to the running state. You might have already come across the life cycle of the process, right? So once it is in ready queue, it goes into the running state. So when it is in the running state means it has been allotted with the CPU and its execution has been started. Right. So what basically CPU does is the CPU will take that process which is there in the beginning of the queue, and it will serve that process completely. When I say completely, to complete its burst time, and then it takes up the next process. Right. So this repeats until all the process in the ready queue has been served. Okay, so this is the introduction to this FCFS scheduling. Let us consider one problem and see. Let's see how exactly it works. Right? So let this be the consider this problem. There are three processes, and respective arrival time and the burst time is given. So this is the standard way in which the question will be asked. You will be given with the process, the arrival time, and the burst time. Generally, what they will ask us to find is the average waiting time and the average turnaround time. By now, you all know what actually there are different terminologies associated, right? So we have something called as completion time, right? We have something called as turnaround time. We have something called as waiting time, right? All these terminologies you have already learned, correct? So the definition of which is very important in order to solve the problem, right? So these are the different terminologies for which you need to know the meaning, right? So it will be good if you know it, right? So these are the different times: completion time, turnaround time, waiting time, burst time, response time, right? Fine, let's start with the problem. As the question is given, first thing that we take is a ready queue. There will be one ready queue where you will be having the processes that arrives in their order of the arrival, that is according to the arrival time given. And then we have something called as Gantt chart, right? Again, this is very important, right? So without Gantt chart, it will be difficult for us to solve the problems. So what basically a Gantt chart is, it is an horizontal bar, a timeline I can say, right, which would help us to understand when the process has arrived, when it has been allotted with the CPU, is the CPU idle or not, right? So when the process is getting completed, all these information is clearly visualized using this Gantt chart, which is an horizontal bar. And so let's write one horizontal bar here. So, right, to begin with, always it starts with 0, 0 second. Let me say it as second. It can be millisecond, it can be hour, or it can be day also. Let us restrict ourselves as second, right? So it on 0 second. If you see this table that is given, at 0 second we have process one arriving, correct? So the process one arrives and it would place itself in the ready queue, right? It will place itself in the ready queue. Now what CPU does is, as soon as it sees P1, there is no other process here. As soon as it sees P1, it will consider that P1 and starts execute and starts its execution, correct? So the execution of P1 starts, and as you can see here, what is the time given? The burst time of the P1 process, it is 5 seconds, which means the process P1 is going to execute for next 5 seconds, right? During this duration, you can carefully observe in this table that the arrival time of the other two processes is 1 second and 2 seconds. Correct, which means even before this process one completes its execution, we will have these two processes, that is P1, P2, and P3 entering into the ready queue. Correct. So, and also I say that this P1 already left, right? P1 left the ready queue. Now, what is there in front? In front for CPU, we have P2. So, will P2 gets executed in between P1 execution? No. As I told, the once the process has been allotted with the CPU, it will complete its execution. Then only the other process will be allotted. Right. So now after 5 seconds, now P2 gets its chance to for its execution. So once P2 gets its chance, it will continue from there, and it will continue for next 3 seconds, which means from 5 to 8, the process P2 is going to execute. So once it leaves the ready queue, the next process that is in queue is P3, which will wait until P2 gets completed. Right. Once P2 is completed, next what happened? P3 will leave the ready queue and it will enter the running state, which means it will be allotted with the CPU. Right. So once CPU is allotted, now the process P3 is getting executed, right? And its burst time is 8 seconds. So until 16, it will be getting executed. Correct? Yes. So now this is the Gantt chart for us, right? So Gantt chart, as I told, it will give, it's a timeline when the process enters, when the process enters the CPU for execution, when it leaves, right? So now based on this Gantt chart, what we can do is we can write a completion time. Right. So writing completion time is not compulsory. However, if we write, it will be helpful for us to carry out the rest of the problem. Right. So what is the completion time of P1? As you can see in this Gantt chart, the completion time of P1 is 5. Right. And whereas the process P2, the completion time is 8. And for process P3, the completion time is what? 16. So it is 16. Okay, so the completion time is now written, and this is it compulsory? No, because it helps us to solve, calculate the turnaround time and thereby the waiting time indirectly. So now it is better to calculate this completion time. Now, once this is done, we shall go for calculating the turnaround time. Now, how shall we what is this turnaround time? See, for that you have to understand this. You know that there is something called as a ready queue, right? So into this ready queue, the process has arrived. So which we I'll come to know with arrival time. Then, so once the process is assigned with the CPU, it enters into the running state. Correct. After some time, it is going to complete. This is completion time. Now, this time period or this window, we call it as turnaround time. That is, I can simply say it is nothing but completion time minus the arrival time. That would give me the turnaround time, right? So the ready queue, it is there. The process is in ready queue. Now it is enters into the running state, and after some time it gets completed. So this time period we call it as turnaround time. Right. So for different processes, what would be the turnaround time now? So based on the values here, we can calculate it easily, right? So let's calculate the turnaround time for process one. Right. So what would be the turnaround time for process one? For process one, turnaround time would be completion time minus its arrival time. So it is 5. And what would be the for process 2? Can you tell, student? Yes. So the completion time is, yes, 8 minus the arrival time of it is what? 1, which is 7. And what would be for process 3? Come on. Yes, very good. So it is 16 minus arrival time. What is it? 2. Good. So it is what? 14. So what would be the turnaround time for the 3 process? The turnaround time for the 3 process for process 1 it is 5 seconds. For process 2 it is 7 seconds. And for process 3 it is 14 seconds. Nice. So now once turnaround time is calculated, we shall go to calculate the waiting time, right? So how do I calculate the waiting time? Now, see, as the other way of defining this turnaround time, right? So how I can tell what is turnaround time? Can I define it in a different way? Yes. What is that? Turnaround time is also nothing but I can say that the time that a particular process waits in the ready queue plus the time it takes for execution. So this is another way in which I can define turnaround time. Right. So from this, now I can say what would be the waiting time. The now waiting time would be what? As you can see from this formula, you can calculate waiting time as what? The turnaround time minus the burst time. Right. Waiting time would be turnaround time minus burst time. Fine. So let's calculate this turnaround time as well, right? So how do I calculate this waiting time now? Uh, for process one, the waiting time would be its turnaround time, which is 5 minus its burst time. What is the burst time? Again, it is 5, so it is 0. So what do you mean by waiting time is 0? It means that the process is not waited in the ready queue only. As soon as it was arrived, as soon as it arrives, it was assigned with the CPU for execution. That's why its waiting time is 0. Similarly, for process 2, its turnaround time, which is 7, minus its burst time, which is 3, which means it is 4. Which means what? Process 2 had waited in ready queue for 4 seconds. So after its arrival, it has waited for 4 seconds before it gets executed. And for process 3, what it would be? 14 minus 8, which is nothing but what? 6. Right? Yes. So let's tabulate this. So that the waiting time for process 1 is 0. Waiting time for process 2 is 4. Waiting time for process 3 is 6. Students, hope you have understood how to calculate the turnaround time and waiting time. This is the simplest algorithm, and it is very easy to calculate, right? Yes. Now, see, this is what was required for us: turnaround time and waiting time. However, sometimes in exam they also ask you to calculate the response time. Now, what is this response time? It is the time at which CPU was allotted first for a particular process minus the arrival time. So that is how I calculate the response time. Okay, so from where will I get this information when the CPU was first allotted? See, it's evident from your Gantt chart, right? So whatever is there to the left of that process, that is the time when it was first allotted. That P1 was allotted as 0th second, P2 was allotted at 5 seconds, and P3 after 8 seconds, right? So how do I calculate the response time? It is first time 0, right? And what was it? What is its arrival time? Right? It is 0 minus 0, which is 0. For process 2, what it will be? For process 2, it is 5 minus 1, which is 4. And for process 3, which is 8 minus 2, which is 6. Right? Correct? So now tabulate this response time. Response time is nothing but 0, 4, 6. Well, students, see, just check here. you can observe that this the waiting time and the response time, they are equal, right? As you can see from this, the waiting time and the response time, they are equal. Correct? Yes. This is a case. This is the case where you are having non-preemptive scheduling. If you are having non-preemptive scheduling, you can say that your waiting time and the response time would be same. This is only for non-preemptive scheduling, students. Fine. Now, are we done with this? No. Now, what I have to do is I have to actually calculate average waiting time and average turnaround time. Okay, so for that, let's consider this table quickly. So we have this turnaround time. So how do I calculate this average turnaround time? Right. So for that, very simple. I have to add all this. That is 5, 7, 14, and then what I will do? I will divide it by 3. So what is that we get? So we get 12 plus 26, right? So 26 by 3. So what would be this 26 by 3? So 3 8s are correct. 8 point. Then what would be 666 or 8.667, right? So that is your average turnaround time. Now, how do you calculate the average waiting time in the similar fashion? It is nothing but 0 plus 4 plus 6 by 3. So that would be 10 by 3. And what is 10 by 3? It is 3.334, right? So this is the average turnaround time and the average waiting time. So once you tabulate the turnaround time and waiting time, you can easily calculate the average turnaround time and average waiting time. However, sometimes if required, you do calculate the response time also. And remember, if the algorithm is non-preemptive, then your waiting time and the response time would be same. Hope you have understood, students. Thank you. We'll meet in the next session with a few more examples. Thank you.